explain why the brain activates differently when the person reads. If you're a normal reader or a dyslexic reader. And as you've seen with functional MRI studies where the brain is activating when you're reading words, dyslexics are not activating in the same way. Of course, we need to know whether that's learned. They learn to use the brain differently. Or whether they cannot use the brain the regular way, so they must do it some other way. And there are ways to study this. We need to explain the abnormal phonological processing, and it's not research that I do directly, but I am involved. At this point, we think that abnormal phonological processing is related to sound processing. They're not hearing the sounds correctly, not phonological grammar. They know about what sounds go together and what combinations are permitted in their own languages and what combinations are not permitted. They know that. But they can't hear some subtle components of the signal, so in the end they cannot have clean representation of the different phonemes of the language. And you need to have a clean representation because each one of those auditory phonemes will match and will map to a particular letter or combination of letters. So the put sound will map to a letter P. The sound will map to a letter C, a combination of CH, something like that. Those are phonemes. They have a normal working memory, but of course, working memory depends very much on perception. So if you have trouble hearing something, you're not going to remember as well because the signal is degraded. The brain is just trying to hold on to it, but it's bad signal, so you will lose it quickly. So we don't know if the working memory issue is primary, which I don't think, otherwise it couldn't be good architects and good engineers. I think that it has to do with the fact that they're trying to remember degraded, poor quality phonological signals. And then again, the thing of being left out in the right hand or ambidextrous. I'll tell you a little bit about the basics. I think I've mentioned some of them. You know, you can study the brain at multiple levels. And the people who study it
Ich verstehe das halt nicht. Das ist super. Ich verstehe nicht. Ich verstehe nicht. Übersetzung ins Deutsche kommt das
so here, obviously, the behavior you're interested in, you will want to understand. Basically, even neuroscientists study this because they want to understand that. We're human beings who like to know why we are the way we are, not necessarily why our genes are the way they are, although that's related. So we can study this at the level of gene structure and function, individual brain cells, and how the cells hook together as small circuits, and how these circuits interact to produce networks. So all the red ones are connected, one in this part of the brain, and one in a different part of the brain, all of which, when they're activated in the proper way, results magically, because we really don't know. There's a code. There's almost like a computer code that translates the neuronal activity in these networks into the ability to move the fingers the proper way. Okay, but this is still a tough part to understand. Okay. The other thing that is important about the basics is that we're not born with this whole thing perfectly made. It has to develop. And that's very logical because you don't know ahead of time whether you're going to be born in Germany, in Austria, or in the United States, or in Biafra. So you can't come in with a machine all stuck, having to do whatever the machine does in the wrong place at the wrong time. So you need to leave some plasticity to adjust the fundamental machine to what you have to do. We do this simply by producing a lot of possibilities and then selecting only the ones we need and getting rid of all the ones you don't need. It's very Darwinian in that sense. We produce many more of everything that we need, and depending on what job you have to do, you get rid of those things you don't need. So if you take a Japanese infant at 3 months of age, he can tell the difference between L sounds and R sounds. No problem. By the time they're 10 months of age, they can no longer tell the difference. They've got, that distinction does not exist in the Japanese language. There are no L's or R's. They make a sound which is somewhere in between if you listen to the Japanese language. And so they get rid of those and they have their own. And that happens with more neurons that you need, more synapses that you need, more gene activity than you need at all levels. You generate more at the beginning, and then you trim it to produce exactly the structure you need to deal with your environment. But you keep it open forever. At least parts of it, because you're always learning throughout life. Okay? There are some things that you keep open less time because you won't need them later on. So language, for instance, has closed class words and open class words. Closed class words are a limited number of words, prepositions, conjunctions, articles, pronouns. And you learn them, and that's it. You learn the number in the language. And so you tend to close that system after a while. But the open class system, where you have to learn new words, you continue to learn new words for the rest of your life, has to stay open. Right? So when you learn a new language, for instance, you're always making mistakes on the closed class words because you don't have a good mechanism for learning new ones. Right? So it's very hard to learn. And even after 50 years of speaking English, when I make mistakes, I still put a Spanish preposition in there. It comes out of nowhere and it surprises me. So the system at the beginning, as you can see, it's very different at all levels. I'll tell you more about it, specific examples. Babies don't read, so they don't have an established reading network at all. Children who are learning to play the piano clearly are using the system very different, are modulating the system, are drawing the system, are trimming away useless things, and by the time you get to be your local Brahms, you are a perfect expert reader, and the system looks very different with reading. It gets smaller, actually. It gets smaller because it gets more specialized. And specialization means trim away useless things and focus and develop the things you need. These are some specific examples. This is from the laboratory Augustin Gombatz in Paris, showing, for instance, in non-readers, children, young children, you see parts of the brain having to do with visual representations. This is the back of the brain where all the visual information comes. After 3 years of reading, this uniform, homogeneous area here has become divided into components that have specialized in different things. In this particular study, this component in green, which notice now is not here on the right side, it's only on the left side, is specialized for words. The red one is specialized for identification of faces, but it's mostly on the right side, as we know. Right side here is the area that has to do with identification of faces, because if you have a stroke or some other injury here, and if you no longer can identify faces, and you get something called prosopagnosia. And there are certain parts of the brain that remain non-specialized for anything else. This is for objects, etc. fact that as you read, compared to the non-reader, the reader here, the non-reader here, the left side becomes twice larger in its ability to control language function compared to the non-reader. So much of the movement to the left side during development for control of language is helped along by learning to read. If you don't learn to read, the both sides remain more or less engaged. Always the left a little more, but because that's the genetic part. But the cultural part helps to move things to the left side even more. Of course, if you've read something about activation of the brain in dyslexics, you know they're always activating the right side more than the normal readers. And you say, well, why is that? Is it because they have not learned to read well, so this push to the left didn't take place? Or is it that something's wrong with the left side, so they can't go to the left, and therefore they can't really specialize, and they'll never read well because it didn't go to the left the way it should have been. So it's hard to know which is the cause and which is the effect, but we have ideas and we have ways to test it. The structure of the brain changes from the beginning to the middle to the end. These are very, very unique photographs. You won't see them too many places. Not too many scientists have seen them. This is from Emi Takahashi in Grant at Children's Hospital in Boston. And this is a picture of connections between neurons in a second trimester fetal brain. And this is already at birth. Look at the changes that have happened in the circuits. These are ways to assess circuits and networks, the way brain cells are connected to one another. And you can see how vertical these are and how more horizontal or more many directions these are. This means that this brain at the very beginning is very concerned with inputs from the outside. What is out there in the world that I have to be concerned about? Okay? And this already begins to prepare the brain to understand relationships between the different things that you experience. Okay? So what does it mean to hear a bell and see a bell? How can we put those two things together so that the concept of a bell comes out that has a sound, has a shape, has a location on the church steeple, has a history, the American War of Independence, the Independence Bell in Philadelphia, the culture that comes with it. So this is possible because you now begin to connect this part of the brain with this part of the brain, not just this part of the brain with the ears or with the eyes. Okay? So this is a reshaping of the networks with development, and it occurs very, very easy. This is an example of what I said before. Initially, you have this brain cell receiving many, many connections, and after learning and being exposed to the world, you now end up with two connections, but they're fatter and bigger, and these are gone. We have very great examples. So this one that my wife was involved with, in which they realized they wanted to know what happens to the information coming